Access rules are highly flexible and can get pretty complicated. Let's create some generic SDK methods to manage them. Sometimes you need more than just getter functionality for a given resource, instead requiring the full suite of create, read, update, and delete actions. Let's implement those actions for access rules. Before we dive in, let's briefly discuss access policies. FTD only appears to support a single access policy as there is no way to create a new one via the REST API. FTD comes with the default policy, and because we need to reference the policy's UUID so frequently, it makes sense to collect this policy one time in the constructor. We'll issue a GET request to the access policy's resource, index the first element from the items list, then extract the UUID. This will save us time and reduce the number of API requests in the future. Adding to our SDK, let's begin with the collection method. It works just like the getSecurityZones method in concept. We can pass in an optional name and filter for rules based on that name. If the name isn't defined, we will collect all rules. Notice how the URL requires the policy ID since we are asking for policy rules within a specific policy. The method returns the response when complete, and here's an example of what that might look like. The FTD sandbox does come with a default rule that we'll delete later in the interest of completeness. Next, let's discuss how to add an access rule. This is significantly more complex than data collection and requires many arguments. The rule name, action, and position are positional arguments that the user must specify. The name must be unique, and the action can be permit, deny, or trust. Trust allows traffic with no IPS or file policy inspection, while permit enables deeper inspection. We'll discuss that later. We begin by creating the HTTP body using these three required values plus the static type of access rule. Then, we update the dictionary with whatever additional keyword arguments were supplied. This dynamic approach captures all of the other rule parameters such as security zones, networks, ports, IPS policies, and more. Here's an example of what the body might look like for a given rule, and we'll see several examples of this in our test script later. Now that we've assembled the rule body, we can issue a post request to the access rules resource supplying the body we just built. Let's reveal the rule name and resulting UUID for troubleshooting purposes and return the HTTP response data. Here's what that might look like, and we'll dig deeper into this using a policy visualization script later. Let's explore how to update an existing rule. This is a bit simpler than adding a new rule. The user must specify the rule ID so the SDK can access the rule along with any keyword arguments that should be updated. Normally, a RESTful put request will replace an entire resource, but I implemented this to be more of a patch-style update process. We assemble the resource URL and issue a GET request for the resource. That will pull down all the current attributes of the rule. Then, we'll update the rule with whatever keyword arguments the user supplied. For example, if a rule has source and destination networks defined, but the user only specified new destination networks, the existing source networks will be retained. We'll issue a put request to the same URL, passing in the rule body and returning the response, which contains the new rule configuration as confirmation. Deletion is important for cleanup and testing, so let's quickly review that. First, we can delete rules by name, simplifying detection when the UUID isn't known. We can leverage the getAccessRules method by searching for a rule with a specific name. We expect there to be exactly one item, and if so, we'll first extract the rule UUID. Then, we'll display a status message indicating we found it. Last, we'll call the deleteAccessRuleID method, which performs the HTTP delete request to delete the rule. Note that the method returns none if no rule was found. Given a UUID, the deletion process is quite simple. Just issue the HTTP delete request to the specific rule URL, print a status message indicating the rule was deleted, and return the response. These requests return an HTTP 204 no content response when they succeed, indicating that there is no HTTP body. If you recall, the rec function just returns an empty dictionary for consistency. Let's add a few rules using the applyPolicy.py script. We'll start off with the two most complex rules. First, we want to permit remote access VPN sessions into the GlobalMantics network from outside to inside. Let's use the same rule name from the ASA configuration earlier in the course. We also specify the action of permit and a rule position of 10, which counts sequentially. Then, we can supply our customized keyword arguments that represent attributes of the rule. In this case, we specify the security zones to describe the flow direction, along with the destination networks and ports. We created these earlier with our VPN network and IPsec port protocol object groups. FTD consumes these items in list format, so we'll encapsulate each dictionary in a list, and naturally, we could add multiple dictionaries if we wanted. The second rule works the same way, except this time we are blacklisting traffic from inside to outside. The action becomes deny, and the security zones are swapped to reverse the flow. We also have to match the specific blacklisted networks, which we created earlier using network objects and groups. For cleanup, let's delete those rules once they are created so we have a fresh working environment for future development work. We can use the delete access rule name method we defined in the SDK. Let's run the script using the Python command shown to check our work so far. I deleted the security zone dumps from earlier, and now we see a transition from object management straight to rule management. After creating all of our objects, we add the two access rules we just reviewed. In the next clip, we'll continue implementing our final access policy.